So glomerular filtration rate, or GFR. This is the volume of filtrate that is produced, right, in this renal corpuscle, and then it's per minute. So glomerular filtration rate is based in net filtration, but summed in both kidneys in all the nephrons. So what determines glomerular filtration rate? Net filtration pressure. That's a big thing. The primary pressure that determines this is glomerular hydrostatic pressure, so blood pressure. We've already seen that with blood pressure regulation. The kidney urine production can be regulated by blood pressure. The other things that determine glomerular filtration rate is going to be surface area for filtration. So what I mean by this is, again, we're adding together all the glomerular capillaries junctions with Bowman's capsules in about 1 million nephrons in all of the kidneys. So when the surface area would change would be, for example, a kidney disease. Otherwise, it's a fairly stable factor. Number 3 is the permeability of our filtration membrane. So something that is determined by the structure, right? Those podocytes and the fenestrated pores. Generally, these capillaries are highly permeable. Compared to other capillaries. So this is going to be regulated. So we're going to regulate GFR by both intrinsic regulation in the kidney and extrinsic, so by the nervous and endocrine systems. Why we want to regulate this? This is going to determine urine production, right? So the volume of filtrate produced, a high GFR, what do you think? That's going to mean we have higher urine output. A low GFR, that's going to mean we have less urine output. So it's the first place where we can regulate urine production. Of course, we're going to regulate reabsorption and secretion as well. One more thing here. So we're talking about filtration right here. All of your plasma, all of your blood is filtered every 20 minutes. How crazy is that? Net filtration pressure is all forces out minus all forces in. So in other words, that is going to be hydrostatic pressure in the glomerular capillaries. That's the only force out because there's not osmotic pressure in the capsular space. That is 0, so we don't need to consider that. If you want to, you can add that. It's always going to be 0. So we're going to take those forces out and subtract the forces in. Forces in are osmotic pressure in the glomerular capillaries plus hydrostatic pressure in the capsular space. So that's 55 minus our 2 forces in are 30 plus 15. Notice you can do this a different way. You can do 55 minus 30 minus 15. Same thing, right? Either way, it is 10 millimeters of mercury. What is that? That's the force out. That's our net filtration pressure. It is positive 10 millimeters of mercury. That is a small pressure, but high enough to allow for glomerular filtration.